Good morning, friends. Let's start our unit test case where we will learn about repartition and coalesce method, that how we can control the number of partitions. So again, I already my IntelliJ I've already created my Spark config object, and here as mentioned that we are passing the master as local star. We already learned in our previous videos that this means that it will create the number of threads, the worker threads or worker nodes, based on the number of CPU cores I have in my laptop. So I've got 4. It means that it will be creating 4 worker threads. So after this, as mentioned, that I will in this unit test case, I will try to do some benchmark testing, in which we will do the benchmarking for both repartition and coalesce methods. That after changing the number of partitions, what is the performance benchmark? For that, I've created a data which will be used, I will be using for creating the RDDs. So it's a list of double, and this number of iteration is that how much iteration I will can go that later. So what I'm doing is that in the before all method, before any test case is done, I will populate this data, that is list of double. What I'm doing is that I'm just creating some random numbers between 100 to 147. So it would be creating data of 1 million and then storing this data into our list of double data. So this is what I'm just initializing with some random numbers of 1 million. After this, in our benchmark test, I would be passing my RDD, which will be created from this data, and I've just marked it as an operation so that we can see that whether it's for repartition or whether it's for coalesce. And we'll do the benchmark testing here. So we will just use this start when we actually do the number of iterations, which is 10. And then for this RDD, we'll just call a reduce operation, where we will be summing all the numbers in this RDD. And then once this sum is done, then we will just print it. And after this, the whole operation for then 10 times across 1 million of data, where we are reducing it for the number of sum, for the total sum of this 1 million double data that we have. And we do this benchmark between these two. And then the time elapsed would be printed here. So this is all about benchmark test. It will show me that how much time it is taking for a particular RDD operation. So let's start our repartition method in Spark RDD. So I already created a Spark context, and now we will write the test case and use this benchmark that how much time it takes. Let me give some space here. First of all, I will try to print something, that what is the number default partition that we have. So for this, I will just mark it say as repartition, and then I will do a default minimum partitions that we have. Because as mentioned in our previous video, that although we have created that local star worker of threads here, we are but still, because the data is not very big, we only have got 1 million of data. So that's why the Spark will, what it will do, it will do is that it will, based on the size of the data, it will have a default minimum partitions across which the RDD is created. For what I mean is that this RDD will be divided according to the number of partitions here, and it would be dependent here that how much partitions are needed for this data. Because our data is small, that's why it would be only having across, I think, 2 maximum. Just by the experience. So, but better to print it down. So we have got minimum partitions and also parallelism that we have. Parallelism means that how many threads it has allocated. So instead of 4, I think it will again drop it down because the data is not that big. It will drop it from default 4 to, I think, 2. Okay, so default parallelism, and I will mark it as %NT, %N, just for new space. And then we will use Spark context. We have got this method already here, which is default minimum partitions. This is what we print here. And then again, Spark context dot default minimum parallelism. So this is based on the data that we create, that the Spark will automatically create it based on the data size. After this, I will just print, make some space here so that we are actually done with starting our test case now. So here, I will first of all, I will create the spark context dot parallelize, and I will pass this data that we have created of 1 million data with some random numbers between 100 to 147, and it will create this, and then I will use 14 partitions. Number of slices would be 14. I'm just trying to change it from the default one so that we can have a good idea about when we change it with the repartition, we have got enough data to be observed. If we choose a default one of 2, then it would not be very visible, then we cannot do a lot of operations on that. So let's make it 14. Okay, so once we do this, Control-V, and then we will store it like my RDD. Okay, and then I will use final here. So we created an RDD here, and let's call this benchmark test. Okay, in the benchmark test, I will be using my RDD, and then I will pass the operation, which is the repartition. Sorry, it's repartition. Okay, so the benchmark test, it will go here with this RDD that we created with 14. And then it will do this operation and do the benchmark at how much time it took. Okay. And similarly, then I will then I will call this repartition method now, which is the goal of this unit test case. So we'll first of all, from 14, I will increase it to 28. We are increasing it to a very high level. Okay. And after when it increases, then we again do this benchmark test that whether it's any impact now after increasing the number of partitions. Of course, it would be poor because it will shuffle all the data between this 14, all the 14 slices that we have created, and it will shuffle it across 28 partitions. So allocation of new partitions, it will be like this operation is going to be expensive. So this is what we are going to test, and then again we reduce it from 14 to 7. So we expect that it should be slightly better than the number of 14 because. From 14 to 7, it would not be very obvious because the data is very less. So even for this 14 slices, it will not be actually creating a lot of the partitions would be empty because the data is not that huge. So 14 and 7 would not be that apparent. I mean, it would be almost similar, but they're definitely increasing the partition from 14 to 28, creating more empty partitions. It would be costly. So let's test this.